Good morning to one and all present here. So I would like to give a small introduction related with PCB board assembly and which would be used in the electronic packaging. So how it is useful for this packaging unit. So the definition reveals that. So what is meant by PCB? So it is going to be a printed circuit board which is made up of an epoxy laminate. So it's a composite material. So laminate material with different layers and all you can have. So how this conductive path? So this conductive paths are etched or printed onto the board. So which would be connected with respect to the different components onto be a PCB such as transistor, resistor and integrated circuits. Classification, we can classify it into a single layer, double layer, or it can be a multi-layer board. So whenever we are taking a multi-layer board, there are a lot of optimizations which we need to make it in the design aspect. So classification is of use when you go with applications. So when we are appending with a lot of applications, so we'll come to know like how it is used in a consumer product. So a lot of products we can list it out which can be used with a less expensive material. So this material whenever it is allowed for a greater tolerance, how much importance we can give it to the electrical properties as well as to the mechanical stability concern. With all those effects we can utilize these boards. So consumer electronics is booming at a larger scale with lot of inbuilt applications where we have this usage which can be focused either for a professional or for a high reliability boards. So there we need some specifications which would be of use whenever we make it for a better quality and also when electrical characteristic is of importance. So this electrical part and environmental specifications if you take, so how the fabrication techniques would be used. And reliability is of high concern when you go with the rapid prototyping of PCB boards. So you can analyze the quality of the base material. So which would be like when you go with the fabrication of ICs and all, it would be with respect to the base substrate material. So here also it is ensured like high quality boards is of use. Otherwise reliability becomes a very absolute. So best quality specifications which are controlled by electrical specs and also high control fabrication techniques. So where we have a process flow. So this process flow, it would be with respect to the fabrication of the board, with respect to a PCB, which is the initial starting raw material which we are taking and into which we have all those deposition scheme, etching process, and then we are making a silk screen top and copper pouring would be there, copper masking would be there, solder mask is there. So all these techniques would be of use. So normally the strategic applications which we are going to prefer. So everything we need to take into care. So when you see this board, so I think this is with a substrate. On to that we have a copper layer. So the usage of copper layer, it is going to have the connectivity part. And again on top where you can see the green color, it's going to be the solder masking part. And again on top where you can see a silk screen. So this we call it as a silk screen top. So when you go with the simulation tool, we have a lot of options to generate this Gerber file. So here the solder side. So why we need a solder side? And before that wiring is going to happen only on one side of the insulating substrate, then we can term it as a single sided. So there the difference lies between a single sided board as well as a double sided board. And when you go with the manufacturing part of this simple circuitry, so it is of with a low cost and how you can have all these components which can be implemented on top of a particular layer, single-sided board, when you can connect with the connectors. So the usage of the connectors is that how it is going to take the input and output of your board. Simple examples have been projected out. So here it is with power supply units, LEDs, all type of LEDs, where nowadays we have lot of LEDs coming in different modules in FM radios, timing circuits, etc. all these related with the manufacturing process where we have the etching and also the die cutting process. So this is implemented with simple circuitry. So this gives you an idea of single-sided as well as a double-sided board. So where complex boards, if you take, the density of the boards are going to be more with more number of components and conductor lines are higher than a single-sided board. Then we can classify this double-sided board too. So the next part it would be with the applications related with the board as well as the layers, and also we have an in-depth analysis with respect to building a PCB. So we'll continue in the next PPT. Okay, in the last video we have seen the double-sided board and classification with single-sided and double-sided. Now we are going to see what is plated through hole. This is the latest part what you have, PTH and non-PTH boards. So as the diagram reveals, so non-plated, plated through holes. Circuitry on both sides if you have. So you can see the circuit which is built. The components are laid on both the sides. So we have a insulating surface. Insulation is provided in order to have a resistance with the current flow. So whenever we have a wire which we are locating it, so plated wire through a hole. So this type we are preferring whenever the circuit complexity, density, number of components which are to be laid on top of the board is going to be larger. When it is with a non-PTH type, we can see the absence of the plate. So there is no wire which are going to be projected out and components are going to be laid. Contacts are made by soldering. So which is a conventional method of soldering, which we have a number of solder joints. So it is going to be kept minimal on the component side if we are going to have it in a non-plated case. So these two difference, they play a vital role in building the double-sided board. So when we go for a multi-layer PCB, so where you can see the outline of this multi-layer where the details are given with respect to the outside layer. This outside layer is going to be projected, which is on top, and this is going to be at the bottom. And here this outside layer, it is with an unetched type of copper. Copper is going to be the conductive material, and the internal layers which are going to subside on here, it is with the etching of copper. These layers we are going to have it as a different stages which we have. Epoxy glass, it would be acting as a laminate. So that would be projecting as a laminate. If it is a 4-layer board, we can consider this pattern. If it's going to be an 8-layer board, so we can go with this type of pattern where 4-layer, so you have this outside layer projecting on both the sides, and in between you have 2 internal layers. But 8 layers, if you see the internal layers, it would be on both the sides. You can make components, or you can have this type of analogy. And here it is used in situations where the density of connections, if you're going to have a very large type, and other reasons what you have for the accurate control of impedance, or it is for the screening purpose. Whether this can be enlarged, it's visible means it's okay, or if it can be enlarged, we can have. In some boards, no, they have as many number of layers, so it is preferable to have like 50 layers also we can have. But even though we are making more number of layers, the wires, the connectivity which is going to be established in each and every layer, it becomes a complex task. So here we call it as a sandwich like structure because it looks like in between layers how we are building, and how it is etched with copper, because copper is going to be the conductive plate. So it looks like a bread sandwich where we call it as a pre-pig formation, and top layer is conventional PCB board, which normal boards which we are seeing, and circuit is completed by means of having various layers onto it through plated holes. A lot of applications we have beneath, like consumer electronics, telecommunication applications if you project, industrial, medical, lot of medical boards are coming in, biomedical type of boards and all. Nowadays we have it very accurate sensing, we sensor boards and all. In automobiles and aerospace is having lot of control units which are built. Rigid and flexible PCBs are also there. So there are a lot of restrictions related to the variety of materials which we are going to use. It may be a flexible, non-flexible type substrate. Base is going to be very thin, laminated or non-laminated, also rigid and flexible, or it can be a volumetric mass if you're going to product. If you are going to produce and gaining a popularity, it's like high efficient boards also you can bring in. So these are the types of boards which we have. And when we go for the manufacturing process, so this manufacturing of PCB is going to be taken care in the next video. So thank you.